So the second way to solve a quadratic equation is rather than factoring, is to use quadratic formula. So remember the quadratic formula is this. And so the quadratic formula can be used with any quadratic equation. And so again, we are talking about ax squared plus bx plus c equals 0. Now remember, when using quadratic formula, you had to look at the coefficient of x squared. The coefficient of x squared here is denoted by what letter? A. Coefficient of x is denoted by what letter? B. And c is called your constant. Okay, that was important. Now when using a quadratic formula, I haven't put it up here yet, but when using a quadratic formula, what has to be on the other side? 0. So 0 has to be on the other side. And so it has to be in general form. All right, so given any quadratic equation, you can solve using the quadratic formula. Now, the last semester you did not see how to derive the quadratic formula because it involved completing the square. So we are going to do completing the square in here next week. We're going to talk about completing the square, but to derive the quadratic formula, you need to use it. So we're not going to use it today, so I'm just going to tell you what the quadratic formula is. So what's your variable here? The variable x. So x is your variable. So the solution would be x equal, now listen to the words. So you're going to have a numerator and a denominator. And so when we state the quadratic formula, we say this. We say the opposite of b, negative b, the opposite of b. So whatever b is, you take the opposite. Plus or minus, remember the plus or minus? The square root of b squared minus 4ac, and all that's being divided by 2a. So that's quadratic formula. So the opposite of b plus or minus the square root of b squared minus 4ac, all divided by 2a. And we didn't talk about that last semester, but in here we are going to talk about what b squared minus 4ac is. So the b squared minus 4ac, we're going to do that later on, not today, but b squared minus 4ac is called the discriminant. Okay, the discriminant. So if you know the discriminant, you can tell right away how many solutions you're going to have and what kind. It's not going to tell you what they are, but you can determine how many you would have and what kind. Yes? I can try, but for today, that's going to be the best I can do. I mean, I can use the wall. The problem is you won't have the video. I can write things. It's up to you. Do you want to write the things or do you want to use the video? Okay, because you're not going to have access to the video if you're absent. See, that doesn't do any good. I'm sorry, turn them all off?
Yeah, we can see.
Y'all okay with it being dark in here? Yeah. Do not fall asleep, because I've fallen asleep in dark rooms before. So it's going to be very... Let me pause this thing. Okay, so... All right, so again, the discriminant doesn't tell you what they are, it just tells you how many you have and what kind. And we'll talk about that later. So let's look at this first example. So number 1, we have 4x squared plus 11x equal 20. So 4x squared plus 11x equal 20. All right, now, when using quadratic formula, you have to determine what a, b, and c are. And it's a good idea to label those. A equals, b equals, c equals. Is c going to be 20? Some say no, some say yes. So, no, c is not going to be 20. Because what do you have to do first? Go to the other side. Okay? So when you bring it to the other side, remember it's got to be in general form. So when you get to the other side, you're going to get 4x squared plus 11x, and then what? Minus 20 equals 0. So once you get in general form, then you denote a, b, and c. So a is what? 4x. No, a is a coefficient. 4. B is a coefficient of x, 11, and C is your constant, negative 20. It's not 20, it's negative 20, because that term's really a negative 20. And so once you get A, B, and C, all it does is just plug and chug. So you plug everything into your formula and you chug it out. Okay, so I get x equal. All right, I'm going to go ahead and draw my division symbol. So remember, the first part says whatever B is, I do what to it? Take the opposite. Well, B is 11, so this becomes what? Negative 11. Plus or minus the square root of. And then what I would do in this case is I would put all these in parentheses. So I'm put B in parentheses. So what's B here?
11.
What am I doing to that 11? Square it. And the reason you need parentheses because if B was negative and you use your calculator, you would, and you didn't put parentheses, you'd get a negative value for B squared. But whenever you multiply something by itself, it needs to be what kind of number? Positive or negative? A negative times a negative is a positive. Positive times a positive is a positive. So B squared should always be what kind of number? Positive, or it could be 0. But can it ever be negative? No. So whenever you do this, this always has to be a positive number or 0. Minus 4 times, notice the parentheses, 4 times A, what's A? 4 times C, and what's C? Negative 20. All divided by 2 times A, and what's A? 4. All right, so that's where I am. So all I did at this point was just plug things into the formula. So now what we're going to do is simplify the discriminant, the radicand. And so when I do that, I get negative 11 plus or minus the square root of. All right, you may need your calculator for this. So 11 times 11 is 121. Okay. All right, now all these are products right here. So a negative 4 times a positive 4 times a negative 20. Use your calculator. First of all, a negative times a positive times a negative will be a what? A negative. So I'm going to say 121 subtract something. 4 times 4 times 20 is what? Use your calculator. What is it? 320? Okay. I'm just writing what you tell me. All over what number? 8. So make sure you use your calculator, and that's what you got. Okay, now, a negative times a positive times a negative is a... Let's do it again. A negative, I wasn't thinking of keeping track of all my negatives. A negative times a positive is a negative. A negative times a negative is a positive. So what should this be? Plus. Okay. All right. So no one caught that. No one caught that. So a negative times a positive is a negative. And a negative times a negative is a positive. Okay. What's 121 plus 320? What is it? 421? 441? Okay. All divided by 8. Okay, now, take your calculator out. Let me see if I can find mine. And so we're going to take the square root of 141. I'm sorry, 441, right? Okay, so square root of 441. So on this calculator, the one I'm using, to get the square root, you see right above the x squared is I guess in blue, that's square root symbol. You can't see it, but on yours, check yours. To get to it, though, I got to press what button? Second. So I say second. Square root. See how what shows up here? You can't see it, but you see it?
Yeah.
Okay. And then I type in 441. Since it's just one number, I don't have to put parentheses. Just say equal. And what do you get? You got 3.3. You did something wrong. You should get what? Square root of 441. What'd you get? 21. You know it can't be 3 point something because first of all, what's 3 times 3? 9. And that's supposed to be 441, right? Okay. So did y'all get 21? All right. Use your calculator. If someone help each other. If you didn't get 440, if you didn't get 21, help each other with your calculator. Your calculator is different than mine probably, so the order in which you do things are going to be different. All right, you got to make sure you know how to use the square root button. All right, now,
I feel like we're doing it just like that, and it's not.
Okay. Now, remember, so we got 21, right? Now, I want to remind you something of why this is 21. So remember the idea of perfect squares in previous courses? So your perfect squares, I'm going to go ahead and just say that right now. Your perfect squares are numbers such as 16. 16 is a perfect square. Because the square root of 16 is exactly an integer. What is that integer? 4. So you get 4. So you get a whole number 4. All right? The one before that would be 9. What's the square root of 9? 3. So these are your perfect squares right here. So if I square 3, I get 9. If I square 4, I get 16. What's the next one after 16? 25, because 5 squared is 25, and the square root of 25 is 5, right? The one before 9 is what? 4, because that's 2 squared. And the one before 4 is 1, because 1 squared is 1. All right, so your smallest perfect square is 1. Now they're an infinite number. The next one after 25 is 6 squared. What's 6 squared? 36. 7 squared? 49. Next one? 64, so on. All right, so these are perfect squares. So 441 obviously is a perfect square because 21 times 21 is what? 441. So that's why you don't have a square root anymore. Now we're going to do some where we still have square roots in our answer, but here we're not going to have a square root in our answer. So we get this perfect square. All right, now what I would do next is since there's no square root here, you break it down to 2 parts, just like this. Break it down to 2 parts. And so basically what you have is how many solutions? 2. Here's how you write them. You're going to say negative 11 plus 21 divided by 8. And the other one is negative 11 minus 21 divided by 8. And so negative 11 plus 21 is 10. So you get 10 eighths. Now, you can leave it as 10 eighths on a worksheet. On my math lab, they may tell you to reduce. If they tell you to reduce, that would be what, 5 fourths? Leave it as an improper fraction. If you want to write as a mixed number, what is that as a mixed number? 1 and 1 fourth. Okay? But you can leave it like this on a worksheet. In my math lab, if they tell you to reduce, you got to go further. Okay, the next one is negative 11 and a negative 21 is negative 32 divided by 8. Now you gotta go ahead and tell me what that is, because that you don't want to leave it like that because it's an integer. What's negative 32 divided by 8? Negative 4. All right, so I do want you to say negative 4 though. So those are your solutions. So 10 eighths and negative 4, or 5 fourths and negative 4. All right. Now, so we did a problem where you ended up with no square roots in your answer. Now keep in mind that these solutions are called rational solutions. Okay, rational solutions. So you may remember that the numbers that you dealt with were either rational or what kind of number? Irrational. So these would be rational. So a rational number is any number that can be written as a fraction, a over b, where a and b are integers. Right, where a and b are integers. So if I look at 10 eighths, and you may say, well, what are integers? Okay, well, your integers are these. There's an infinite number of those, so we're going to start with 0. So I have 0, 1, 2, 3, 4, and so on. And then I also have -1, -2, and so on. So those are your integers. So you don't see any decimals, right? You don't see any fractions. They're all whole numbers and the opposites. So if we look at 10/8, is 10 an integer? Yes. Is 8 an integer? 8's not an integer? Yeah, 8's an integer. It's a whole number. Is -4 a rational number? Yeah, because -4 I can write as -4 over what? 1, and -4 is an integer, will be listed, and 1's an integer. So a rational number is just any number that can be written as a fraction where you have an integer over an integer. So for example, one of the things you learned in the past was this. So just asking if you think this is a rational number. Is 2.7 a rational number? So remember, the definition of rational number is a number that can be written as a fraction.
Yes.
How do you read this? I read it as 2.7. I read it incorrectly because that's the way we normally say it, but that's not really 2.7. That's 2 and what? 7/10. That's 2 and 7/10. So I can write this as 2 and 7/10, and then I can write that mixed number back as a fraction, right? An improper fraction. 10 times 2 is 20. 20 plus 7 is 27. So this is 27 divided by 10. Is 27 an integer? Is 10 an integer? Yeah. So back to the question. Is 2.7 a rational number? Yeah. One of the things you learned was that any decimal that terminates is a rational number. You can always write a terminating decimal as a mixed number. The other thing you learned about rational numbers in the past was something like this. Let's see. Is 0.333 repeating a rational number? I don't think so. What is 1/3? Put 1/3 in your calculator. 1 divided by 3. What do you get?
3.
You get that, right?
Yeah.
Isn't 1/3 a rational number? Mm-hmm. So is that a rational number? Yes. So you and if you don't use it, you forget it. So almost all of you did not know that. First of all, 0.333 is 1/3, but it is a rational number. So any decimal that repeats is also a what? Rational number. So one of the things you learned in the past was any integer is a rational number. Any fraction where you have an integer of an integer is a rational number. Any decimal that terminates or repeats is a rational number. So when you do the quadratic formula, when you solve an equation by quadratic formula, some will be rational, some will be what? Irrational. And some will be imaginary. Remember the eyes? Mm-hmm. Okay, we're going to go to that next time. So some will be rational. If it's rational, then I want you to do it this way. I want you to break it apart like this. Okay? So I need for you to go further. If it's a rational number, meaning that when you don't have a square root anymore, go further. Okay? If it's irrational, we're going to do one. If it's irrational, then you're probably going to have to tweak it a little bit to what you need to get to. All right. So if a number's not rational, then it's what? Irrational. So the most common irrational number you dealt with in high school was the number pi. Pi is an irrational number. So on your calculator, you do have a pi button on your calculator. If I can find mine. Let's see, where's mine? Yeah, it's right here. See right here? All right, so if I punch that, and then say equal, I get this. So I get 3.141592654 and so on. So it doesn't terminate, but it's okay because we saw that 1/3 doesn't terminate, but it was still a what? A rational number. But it's still a rational number because it repeated, right? There was some repetition. If you look at pi, do you see anything on your calculator that's starting to repeat in parts? No, there isn't any. So that's why you can't represent this as a fraction. So we use a Greek letter to represent this irrational number. So pi is an irrational number. The square root of 16. Is the square root of 16 rational or irrational? It's rational because the square root of 16 equals what? 4. So that's rational. So square root of 16, which is 4, is a rational number. The square root of 8. Rational or irrational? Okay, if you say rational, then you should be able to write the square root of 8 as a fraction, an integer divided by an integer. What is it? It's irrational. Square root of 8 is an irrational number. So if you punch in the square root of 8, you get 2. I'm going to do it here. You get approximately 2.828427125 and so on. There's no repetition there. You can't write the square root of 8 as a rational number. It's not a rational number, it's an irrational number. In the quadratic form, we're dealing with square root, right? The only way you're going to get a rational number is if the discriminant is a perfect square. Is 8 a perfect square? No. Is 16 a perfect square? Yeah. Rational. 8's not a perfect square. So the square root of 8 is what kind of number? Irrational. So when we solve these quadratic equations, some will be rational and some will be irrational. It will be rational if the radicand is what kind of number? Perfect square. If it's not a perfect square, you're going to end up with a square root in your answer. It will be irrational. Okay? So you can see how that's going to look. Okay, let's do this one. So this will be number 2. Number 2. So don't forget, this one was irrational. All right, number 2, let's suppose we had x squared plus 3x minus 6 equals 0. X squared plus 3x minus 6 equals 0. All right, so I solve this quadratic equation. And make sure you read the directions because the worksheet you're going to get, it'll say solve using factoring, solve using quadratic formula, solve using completing the square, which we hadn't talked about yet. But read the directions. But if you try this one by factoring, it's not going to work. You can't factor that. So x squared plus 3x minus 6 is prime, so you can't factor it. So you have to resort to using what to solve this? Quadratic formula. All right, is it in descending order?
Yes.
Is it in general form?
Yes.
Okay. So what's A? 1. Coefficient of x squared. What's B?
3.
And what's C? Negative 6. It does matter because if you said 6, you get a different answer. You gotta keep the sign. All right, so we're gonna plug into our formula. So x equal remember it's the opposite of b. So b is 3. What do I get? Negative 3. Plus or minus the square root of, in parentheses, I'm gonna put 3. And what do I do to that? Square it. Minus 4 times a. What's a?
1.
And what's c?
Negative 6.
Okay, all divided by 2 times a. And what's a? 1. All right, so I'm going to simplify the radicand. So I get negative 3 plus or minus the square root of, what's 3 squared? All right, now a negative times a positive is a negative. A negative times a negative is a positive. It'll be a plus. What's 4 times 1 times 6? 24. So you get 9 plus 24, right? All right, all divided by 2. And what's 9 plus 24? 33. all divided by 2. All right, so that's where I'm at. Now, is 33 a perfect square? No. So you can't do anything with the square root of 33 in terms of writing it as a rational number, because it's not a rational number, it's a irrational number. One of the things you learned last semester was also simplifying square roots. So in my math lab, they may ask you to simplify. But in here, you can leave it like this, I'll be fine. And you really can't simplify this to begin with. But remember this right here, if I ask you to simplify the square root of 24, let's do 24 right now. You got to go back to something you had in the past. All right, so we're dealing with square roots in here. We ask ourselves, well, first of all, is 24 a perfect square? No. But then you ask yourself, is there a perfect square? Use the largest. Is there a perfect square that goes into 24? Yes. What is it? 4. 4. All right, so then what you did was you wrote this as the square root of 4 times 6, right? Yeah. Okay, 4 times 6, 24. And then what you then did was you broke it down to 2 parts in a product. You said, well, that's going to be the square root of 4 times the square root of what? 6. And the square root of 4 is also what? 2. So you got 2 square root of 6. So that's how you simplify the square root of 24. So the square root of 24 is 2 square root of 6. You use ideal perfect squares. So, but if I go back to square root of 33, is there a perfect square other than 1 that goes into 33? No. So can I simplify the square root of 33? No. So leave your answer like that. You're done. Now, I'm going to say this. So this is fine, leaving the answer like this. You can also, in my math lab, let me say about my math lab. My math lab, they're going to ask you to rewrite this as 2 separate solutions. So I'm going to put my math lab here. So in my math lab, they're going to want you to break it apart in 2 separate solutions. So what you're going to do is you're going to say negative 3 plus the square root of 33 divided by 2. And then negative 3 minus the square root of 33 divided by 2. Now, in my math lab, remember when you put things in the computer, you got to be careful your syntax. Mm-hmm. So if you do this in my math lab, when you get to that part, if you say this, negative 3 plus the square root of 33, and then say divide by 2, that's not the same thing as this. The only thing you're dividing by 2 is square root of 33. So my math lab, you don't do it like that. I think what they're going to give you when you put it in my math lab, you're going to get you'll see it. You're going to get a little division bar, I guess. You just put the numerator there, and then you just put the denominator. So don't write it like this. You got to actually use that fraction. It looks like a fraction bar. And you just put the numerator to the denominator. So you get multiple tries anyway. So if you mess up the first time, do it again. Okay? All right. So this is what kind of solution? Irrational. So these are irrational solutions. So sometimes you're going to get irrational solutions. Sometimes you're going to get rational solutions. If it's rational solutions, it looks like this. Your answer will look like this. If it's irrational solutions, you're going to end up with a square root in it. Okay? Don't worry about simplifying the square root unless it's my math lab. All right, question number 2. All right, let's do one more. I think I'll do one more with this. So let's look at this one. All right, so let's look at this one. So this will be number 3. All right, you have 2x squared equal 1 plus 4x. 2x squared equal 1 plus 4x. What kind of equation is this? Quadratic. So you're going to, just to be on the safe side, because it may or may not be factorable, just use the quadratic formula. But regardless if I try to factor, if I use quadratic formula, is this in the right form? No. So I got to bring everything to one side. I must have what in the other side? 0. So 2x squared put in descending order as well. What do I write? 2x squared, what else? Minus 4x, what else? And equal what? 0. Okay. So remember, when you bring a term from one side of the equation to the other, the sign changes. So what is A? 2. Okay, A is 2. What is B? Negative 4. You got to keep the sign. So it's negative 4. And what is C? Negative 1. So you got to be careful. We see if any of those is incorrect, then all the stuff you do after that is going to be wrong. You have to keep the sign. So B is negative 4. That's a negative 4x. Not a 4x, it's a negative 4x. It's not a 1, it's a negative 1. And then all we do now is just plug into the formula. So I get x equal the opposite of B. What's the opposite of B? 4. Positive 4. Because B is negative 4, the opposite of that is a positive 4. Plus or minus the square root of, remember parentheses, negative 4 in parentheses. What do I do to that? Squared. Minus 4 times A, what's A? 2 times C, and what's C? Negative 1. All divided by 2 times A, and what's A? 2. Okay? See that negative 4 in parentheses? That would be important, because if you didn't put in parentheses and use your calculator and you said negative 4 squared, you would get a negative 16. And B squared should always be what kind of number other than 0? Positive. So a negative 4 times a negative 4 is a positive 16. So I get 4 plus or minus the square root of 16. All right, let's look at the next one. A negative 4 times 2 is a negative 8, right? A negative 8 times a negative 1 is a positive 8. All divided by 4. All right, go further. 16 plus 8. 24. All divided by 4, right? Okay, so that's where we're at. Now, 24, is 24 a perfect square? No. So I'm an interval, what kind of solutions? Irrational. All right. Now, just like we did in the previous one, we left it like this. We left it as negative 3 plus or minus the square root of 33 over 2. And part of the reason we did that is because we knew the square root of 33 could not be simplified. So in my math lab, though, you can't leave it like this. Because if you look at 24, is there a perfect square other than one that goes into 24? Yeah. So in my math lab, you have to go off to the side and simplify the square root of 24 using the idea of perfect squares. You got to use the largest. What's the largest perfect square that goes into 24? So I got 4 times 6, and the square root of 4 is what? 2. So that's 2 square root of 6. So that goes here. So I got 4 plus or minus 2 square root of 6 all over what? 4. That's where we're at. In my math lab, I was going to tell you to simplify. So simplify further. So if you look at this, you see what's the way that somebody's going to mess up is this. You're going to say, oh, I see some 4s here. And so you're going to say this. You're going to say, and it's happened. Someone asked you this. You're going to say the 4s divide out, and you're going to say, well, that's going to be 1 plus or minus 2 square root of 6 over 1, right? Is that correct? No, that's good. I'm glad you realize that it's not correct. Because by doing that, what you're saying is that this denominator is only being divided into this part, but it's also being divided into what? That part as well. So you can't just reduce one part like that. So the way I would do this is this, so that's not correct. I would look at, see I'm going to go ahead and rewrite this. See these things I'm circling right here? I'm leaving the square root alone. Those things, are all those 3 things that have circles divisible by a number? Which one? 2. So let's divide everything by 2. So they're all divisible by 2, right? 4 divided by 2? 2. Plus or minus 2 divided by 2? So it's just square root of 6, right? All over what? 2. And there's your answer. So in my math lab, this is certainly what they're going to want, but you have to separate the 2 parts into 2 solutions. So in my math lab, you're going to say 2 plus the square root of 6 over 2, and what's the other?
Minus the square root of
2 minus square root of 6 over 2. Don't reduce the 2's. You know you can't do that, right? Because the same idea. If you say I'm going to reduce these 2's, well, you forget the fact that this is also being divided to what? Square root of 6. Okay. All right, so those are irrational solutions. Now, for the most part of the worksheet, unless I tell you to simplify, you can leave it like this. If I tell you to simplify, then yeah, I'm going to want you to go further because I need you to practice with this. All right, so if it does say simplify, do go further. So let's kind of look at this. I'm not going to do another problem. We're going to work more with this next time. But I want to ask you this. If I ask you to simplify, let's say you did your work and you had something like this. 8 plus or minus the square root of 5 divided by 2. And just leave it as one fraction. Can I simplify this? No. Cannot simplify this. So you cannot simplify. You may say, what about the 2 and the 8? Well, you got to be careful because 2 is divided into 8, but also 2 is divided into what? Square root of 5. Okay? What if I had this? 8 plus or minus the square root of 5. Oops, sorry. 2 square root of 5 divided by 2. Then could I simplify? Yes. Now you can simplify. Because if I look at these 3 things I have circled, they're all divisible by what? 2. So I get 4 plus or minus the square root of 5 all over what?
2.
No, not 2. 1. They're all divisible by 2, right? But anything divided by 1 is that numerator, so it's just what?
4
Square root of 5. All right, so the point is this. You do understand that if you do this, so let's say we had 6. You do understand that if you say this, 2 and a 6 is 3, 2 and an 8 is 4, and you say that's 4 plus or minus square root of 5 over 3, you do know that's incorrect, right? Mm-hmm. Okay, good. That's incorrect. Because not only is the 6 being divided into 8, it's also being divided into square root of 5. All right, so just try not to make that mistake on a worksheet where you get it correct and all of a sudden you go further and you mess up. Okay, so be careful. All right. Now, one other thing and we're going to talk more about complex numbers. Remember y'all talked about complex numbers last semester? The only thing you did last semester in terms of complex numbers was this. On your calculator, what's this? Well, you don't need a calculator for that, but what's the square root of 4? 2. On your calculator, though, what's the square root of a negative 4? Is it negative 2? No, because remember, the square root of 4 is 2 because 2 times 2 is what? 4. The square root of negative 4 is not negative 2. So that's not negative 2. Because negative 2 times a negative 2 is a what? Positive 4. That's not a positive 4, that's a negative 4. So remember we had that conversation last semester? And so we saw that if you were to put that in your calculator, you would get something like a domain error or something like that. So it's not a real number. So the square root of negative 4 is not a real number. But all those rational and irrational, those are real numbers. So all the solutions we had a while ago, those are real numbers, right? They're either rational or what? Irrational. Now we get into a situation where they're not real numbers, but you have to still deal with them. And so remember last semester we talked about a new set of numbers called imaginary numbers? So here's, and we'll talk more about this next time, but here's what I just want you to remember about that. The square root of a negative 1 was defined to be what? I. Square root of a negative 1 was defined to be I. I for imaginary. So square root of negative 1 is defined to be I. So what you did last semester was that, all right, you had practice with that, and then we go back to the square root of a negative 4. And that one was easy to where you could just tell me right away what that is. What's the square root of negative 4? Don't say not a real number. You understand what it is in terms of imaginary numbers. 2i. Square root of negative 4 is 2i. And what we did to get that 2i first was we said, well, I know that square root of a negative 4 is the square root of a negative 1 times 4, right? And then I can rewrite this as a square root of a negative 1 times the square root of 4, right?
Right.
The square root of a negative 1 I know is defined to be I. The square root of 4 I know is 2. But we also talked about the fact that we don't write I2, we write what? 2i. We tend to put the I behind the coefficient. So that was a conversation we had last semester. And so if you had something like the square root of a negative 16, we knew right away that that was 4i. Okay? It's not a real number, but we now know it's an imaginary number, and we can deal with imaginary numbers. So that's 4i. Okay? Now, next class period, we're going to talk more about complex numbers. All you did last semester was this idea, and then you use it with quadratic equations. So notice that in all the quadratic equations we did, do we have any imaginary solutions? No. They were either rational or irrational. Next class period, we're going to do one where it's imaginary. So you are going to have that I. It's not time to go yet, though. You're going to get that I.
I think your email said 10:15.
I know, I was wrong. It's 10:30. It's 2.5 hours. Yeah, I was wrong. I had to tell the other class theirs starts at 10:45, not 10:30. So, all right. Okay. All right. So what I want you to do, let me go ahead and turn this off.